Introduction to Product Planning. In this video, we are going to see about Introduction to Product Planning. Product planning is defined as the evaluation of the range, mix, specification and pricing of existing and new products. New product relation to present and future marketplace necessities and competition, preparation of product range, mix, specification and pricing to satisfy company objectives, and specify the research, design and development support required. Organizations that do not carefully plan the portfolio of development projects to pursue are often plagued with inefficiencies such as inadequate coverage of target markets with competitive products, poor timing of market introduction of products, mismatches between aggregate development capacity and the number of projects pursued, poor distribution of resources with some projects overstaffed and other understaffed, initiation and subsequent cancellation of ill-conceived projects, frequent changes in the direction of projects. Product development projects are new product platforms, derivatives of existing product platforms, incremental improvement to existing products, fundamentally new products. Defining the task. Product development projects involve the completion of hundreds or even thousands of tasks. This section discusses some of the fundamental characteristics of interacting tasks, the basic physics of projects. We also present three ways to represent the task in a project: sequential task, parallel task, coupled task. Sequential task. Sequential task shows three tasks, two of which are dependent on the output of another task. These tasks are sequential because the dependencies impose a sequential order in which the task must be completed. Generally, the later task can begin with partial information but cannot finish until the earlier task has been completed. Parallel task. Parallel task shows four development tasks. The middle two tasks depend only on the task on the left but not on each other. The task on the right depends on the middle two tasks. We call the middle two tasks parallel because they are both dependent on the same task but are independent of each other. Coupled task. Coupled task shows 5 development tasks, 3 of which are coupled. Coupled tasks are mutually dependent. Each task requires the result of the other task in order to be completed. Coupled tasks either must be executed simultaneously with continual exchanges of information or must be carried out in an iterative fashion. Scheduling the task. In this video, we are going to see about scheduling the task. It contains deciding as to when the work will start and in certain duration of time how much work will be finished. Scheduling deals with orders and machines. That is, it defines which command will be taken up on which mechanism and in which section by which operative. While doing so, the aim is to schedule as large amount of work as the plant facilities can suitably handle by keeping a free flow of material along the making line. Scheduling may be called the time phase of loading. Loading means the assignment of task or effort to a facility, whereas scheduling includes, in addition, the requirement of time and sequence in which the order or work will be taken up. Gantt charts. The traditional tool for representing the timing of task is the Gantt chart. The chart contains a horizontal timeline created by drawing a horizontal bar representing the start and end of each task. The vertical line in shows the current date, so we can observe directly that task D is behind schedule, while task E is ahead of schedule. A Gantt chart does not explicitly display the dependencies among tasks. Task dependencies constrain but do not fully determine the timing of the task. The dependencies dictate which task must be completed before others can begin or finish, depending on the nature of the dependencies and which task can be completed in parallel. When two tasks overlap in time on a Gantt chart, they may be parallel, sequential, or iteratively coupled. Parallel tasks can be overlapped in time for convenience in project scheduling because they do not depend on one another. Sequential tasks might be overlapped in time, depending on the exact nature of the information dependencies as described below in the section on accelerating projects. Coupled tasks must be overlapped in time because they need to be addressed simultaneously or in an iterative fashion. Estimation of labor cost and amount of documentation. In this video, we are going to see about estimation of labor cost and amount of documentation. To estimate the labor cost, we need to know two things: the time it takes to complete the task and the wage rate. Any text on motion and time study can be used to learn the details of time study equipment and the procedure used in determining time it takes to complete the task. The procedure is described briefly and in simple terms below. The first step in determining the time required is to observe the task being performed and record the time it takes to complete the entire cycle of the task. The time for a number of task cycles is recorded and averaged. That is, in general, the number of task cycles recorded should be sufficient to include most variations in the method and pace of the operator. This average cycle time is called the observed time. This observed time is modified by multiplying it with a factor called the rating. The rating is the pace at which the operator being observed works. A normal worker, that is someone who is suitably motivated and has adequate experience is considered to work at a normal pace or 100% rating. This allows for a longer normal time if the observed worker is working faster and shorter normal time if the observed worker is working slower than a normal worker. When the observed time is multiplied by the rating, the resulting time is called the normal time. This normal time is modified by adding allowances for personal needs, unavoidable delays, and fatigue, that is PDF, to determine the standard time. The standard time is also known as the job standard. The following relationships clarify how the job standard is developed. Average observed time is equal to total time for X complete cycles of the task or X. Normal time is equal to average observed time into rating. Standard time is equal to normal time by 1 PDF allowances. The PDF allowances are the fraction of the normal time devoted to personal needs, unavoidable delays, and recovery from fatigue. The standard time may be expressed in seconds, minutes, or hours. The standard time may be used to determine output per hour in terms of number of pieces as follows. Pieces per hour is equal to 60 per standard time in minutes. Standard output per day is equal to pieces per hour into 8 hours pieces. From the preceding, the direct labor cost can be calculated as follows. Note that the wage rate may or may not include the cost of fringe benefits. If such cost is not included, the wage rate must be modified to accommodate it. The actual wage in that case is actual wage rate is equal to wage rate into 1 plus F plus U plus W plus H, where F is equal to FICA fraction, U is equal to unemployment compensation fraction, W is equal to workers' compensation fraction, H is equal to health and other insurance compensation fraction. Sometimes it is necessary to modify the time per unit to account for the effect of learning. This may be done as follows. Time T per piece after a cumulative production P is equal to T naught into P to the power of N, where P is equal to cumulative production, T naught is equal to time to make the first unit, N is equal to the learning rate. It may not be possible to observe the job being performed to establish job standards. For instance, when the production facility is being planned and the job does not exist. In such situations, it is recommended that a predetermined motion time system, that is PMTS, be used. Several kinds of PMTs are widely available. Among the most popular are MTM, PMTS, and the work factor PMTS. MTM is the most popular. MTM analysis requires that a job or operation be broken down into fundamental elements. The time for these fundamental elements is predetermined and available in widely published tables. The time for the job is determined by adding times for all the elements. The PDF allowances should be added as shown for establishing job standards. Another technique is useful in determining time taken to perform a job when several people work on the job or the work is non-repetitive in nature is work sampling. This method requires observing the activity at random times and note if the person, that is S, is engaged in performing the activity or not. The number of observations can be determined statistically from the binomial distribution. Based on the person being busy or not, a fraction p indicating the proportion of times the person is busy is determined as follows. P is equal to hash of times person engaged in the activity or total hash of observations. Once the value of P is established, it can be used to determine the actual time for the job. For instance, one may be interested in knowing the time it takes to just paint a house, not cleaning or preparing to paint it, or after painting cleanup. Let us say that the observer found that over a period of 4 weeks, this person was found actually painting the house 70% of the time. In other words, P was observed to be 0.70. The person worked 8 hours for 5 days every week and painted 4 houses. The time for actually painting the house is 0.7 into 8 hours into 5 days into 4 weeks per 4 houses, 28 hours by house. If several people were engaged in the task, the time could be determined similarly.